So this question is asked to balance the equation first and then to calculate the E for both reactions. So for the first one, we break it down into two half reactions, which is CO solid turning into CO2 plus aqueous. We keep the states, keep the phases because we later need it to determine which reaction it is. And for the second one, it's H plus aqueous to H2 gas. If you look at the first one, there's H2 CO on both sides, which means that we only need 2 electrons to balance the first reaction. And for the second one, we need 2 H's on both sides. That's why I multiply the H on the left. And now we have plus 2 on the left, meaning that I need 2 other electrons to balance it out. Okay, so now before we write out the final balanced equation, we look for the E value first, since it's already in half reaction form. So by looking at the first one, which is this reaction, we can find out that it's corresponding to this one, but reversed, telling that the value here is negative 0.28. Because it's reversed, it's going to be plus 0.28 for A. And then for the second reaction, if we find the counterpart of it, as we can tell, it's exactly the same with the one here. Well, it doesn't really matter if it's reversed or not since it's 0, but we need to know that it's on the same direction, so we don't have to reverse it. So it's going to keep the same signs, and it's going to be 0. So the E for A is going to be 0.28 as you add them together. And the final equation is just going to be 2H plus CO goes to CO2 plus H2. And for B, we can write it into two half reactions, which is Hg2 2 plus aqueous going to Hg2 plus aqueous, and then we use the left side again, Hg2 2 plus aqueous going to Hg liquid. So now we need to balance it again. We need 2 Hg's on both sides. We just add a 2 here, and then the 2 are balanced, but they're this plus 2, and this is plus 4. So we need to add 2 more electrons on the right. And then we do the same thing here, 2 Hg's, 2 Hg's, and we add 2 electrons on the left side. So we're trying to find the same equation from Appendix D. We can see that this one is corresponding to this reaction, but reversed. So the 0.92 here is going to be negative 0.92 because it is reversed. And then this reaction is the same with this one, so we don't have to do anything about it. We just keep the 0.85 of which it is said. By knowing these two numbers, we just add them up and tell that the E for this question is equal to negative 0.07. And for the last state, we just copy down the balanced equation, which is Hg second 2 plus aqueous going to Hg2 plus Hg liquid. Okay.